Hi, I'm Professor Frank, and today we start the first part of the chemistry lectures. And today's lecture is a brief one, and then it's going to be a slight survey of what we're going to be doing over the course of the next few months. But today's lecture is about what is chemistry. So what is chemistry? Well, chemistry is the study of matter at the atomic level and the molecular level. So what does that mean? Well, for instance, let's say water. When chemists think of water, we don't just look at water, we write down what the formula is for water, which is H2O. And even further, we look at the individual atoms within a water molecule. So you have one oxygen and two hydrogen. Okay? So each individual atoms make up one water molecule. And so that's where chemists reside at, is the atomic and molecular level. So at the atomic level, we're talking about atoms. And when we talk about an atom, and you've probably come across this in your high school chemistry, or even sometimes it's briefly talked about in biology or your life science class that you may have taken in 9th grade. With an atom, you have a nucleus, and inside the nucleus we have some protons and some neutrons, and then outside we have electrons. So that's a basic atom. Okay, so this is the level that we hang out in, and we say what happens at the atomic level. Well, what we have are atoms, of course, and then we also have what are called bonds, which are links between different atoms. Okay, and chemists not only like to study the individual atom, but we like to study the bonds of molecules, and also the bonding between different molecules. So that's what chemistry is. Now, we also like to talk about not only atoms and molecules, but not all chemical compounds are molecules. For instance, we might have sodium chloride. Sodium chloride is a chemical compound, but it's not a molecule. And we'll get into this over the course of the lectures, but sodium chloride is a solid, and it's not a molecule, it's a crystal. And you have individual sodium plus ions and individual Cl minus or chlorine ions that are linked together in a crystal structure. So we call those crystalline compounds. Okay? So water is a molecule, sodium chloride is found in a crystalline compound, but these are the types of things that we study. Atoms, molecules, crystalline compounds, and the bonding between them all. Okay? What else are we going to talk about over the course of the next few months? Well, we're of course going to be talking about the periodic table, and you've probably come across this again. If not, if you're a college student, you've come across it in high school. If you're a high school student, you've probably already covered it in 9th grade life science. But of course, you probably remember the periodic table is pretty much a rectangle, and you have a bunch of different elements in there and so forth. Okay, and what we're going to talk about within the periodic table, there are certain trends. So as we go down a column, there's a trend. As we go from left to right in a row, there's a trend. And there are a bunch of different trends, and it's really cool when you see what's going on when you move down a column or left to right in a row, all the different trends. You don't necessarily have to memorize things. You can, if you just understand it, you'll be able to predict things that will happen for certain elements, or in particular reactions, you can predict things that will happen. So, for instance, there's a column called the halides, or excuse me, the halogens. You have fluorine, chlorine, bromine, and iodide. And, you know, if you see chlorine reacting a certain way, then bromine might react a certain way as well, because it's in the same column. So it can be pretty cool when we delve into that. Then after the periodic table, or maybe before, we'll talk about the naming of compounds. So just, you know, the simplest example, NaCl, sodium chloride, and I'll talk about why it's, or how we come up with that name, and we'll talk about naming a bunch of different compounds, and what there are probably like a half a dozen types of groups of compounds, and once you were able to understand the name of one compound, you can name all the others. It's not too difficult. We'll also talk about equations, of the form you have A plus B going to C plus D, okay? And not only that, sometimes we're going to have numbers in front of the whatever this is. This could be a molecule, it could be an ion, or it could be sodium chloride, and we're gonna get into balancing the equations. So let's say you have so many hydrogens on this side. Let's say you have 4 on this side, then you would have to have 4 on that side. And let's say you have 2 oxygens on this side, then you'd have to have 2 oxygens on that side. So just balancing it out. And it's really not too difficult. There's some rules you have to follow and an order in which you do them. And it's really, of course, it has to do with chemistry, but if you just look at it in terms of how you'll solve these problems, it really doesn't have anything to do with chemistry. It's just a puzzle. So that's not going to be too difficult. And then, this is an equation. And there are different types of equations, meaning there are different types of reactions, like reactions that form a salt, or reactions that give off a gas. And we'll talk about all those types of different reactions, okay? And throughout the course of doing this intro chemistry, there's going to be some math involved, but the math isn't, it's not calculus, it's not trigonometry, it's just basic math, multiplication and division, of course applied to chemistry. But again, that's not going to be too difficult, and if you just kind of work your way up and go slow, you should be able to do it without too many problems. And then, as we go along, the next phase, once you get those things down, what we'll start to do is we'll start to be able to draw molecules, like, let's say, carbon dioxide and water, or ammonia, okay? And you say, well, how do we draw these molecules? How are these, you have a nitrogen and 2 hydrogens. How are those 4 atoms arranged? Well, in the case of ammonia, they're arranged like this. Okay? And, how do we arrive there? And what these are called, these depictions of molecules in a 2-dimensional space, these are called Lewis structures. So we'll do Lewis structures. And Lewis structures are very, very important. Even if you're a high-level chemist, you're still going to be drawing Lewis structures. So it's a very fundamental and foundational tool to use to be able to draw Lewis structures. So that's very important. Once you get going, once you try some examples and draw, you know, a few dozen Lewis structures, it'll get very easy, and it's kind of a practice. It gets easier, and you get better as you go along, and it can be fun too. So those are just some of the things that I'm going to cover over the next few months. Again, like I said, introductory chemistry doesn't have to be challenging. You can do it. It can even be fun. As you can see, there are a bunch of different things, you know, types of learning that will be involved, and different areas of your brain that will be used. And you know, don't kind of psych yourself out, you know, because there are so many different aspects to introductory chemistry. You're bound to be good at a few of them. You might not be good at all of them, but you'll be good at least some of them. And with that, I'll see you next time for part 2.